So time to start working on your microphone, provided by Gauge Precision. So I'll start off building this components on the circuit boards. And I always like to start with the smallest components first. I'll start with the resistors and then build up to the taller ones. That makes it easier to hold them in place. We're going to start with this circuit board first. Looks like this. If your circuit boards have this extra little piece on them, just take your pliers, the wider ones, grab a hold of that, and break it off. And then go ahead and mount it in your PC board holder. So the two spots in the middle where there are holes, just line those up on the mounts. So there's a thinner slot and a wider slot going the short direction, so put it in those. I like to push it in until this spring is about half compressed. Tighten it up, not too tight because we'll destroy these. So that lets me move it around, but it pretty much holds in place. Okay, a little too zoomed. So I'm just going to start from the components I see up here in the top and go across. If you want to do them in order like R1 to R2, you can do that, whatever you prefer. So I'm going to start with R6 and R14. So the components are all in a little drawered enclosure. Let me show you. Like this. I have a good way to show it on the camera. That's it. It'll be in the lab for you. So you can grab the components as you need them. I didn't get them in time to really sort them for each individual person, and I think this will work better anyway. So I'm going to start with, up here in the corner with R6. Grab my R6 value, which is a 2.2 kilo ohm resistor. And then a lot of times we'll use these lead benders, but on this particular project, all the resistors are bent right on their edges. So just go ahead and bend it so the lead's bent right to the edge of the body of the component. And that fits right into the board. Push it all the way down. Then R14. And this is fairly easy for me because I have the drawer sitting right in front of me. You'll want to grab components as you need them. If you want to grab all your components at once, you could, but then you're going to have to sort them in some way. So I think grabbing them as you need them makes a lot more sense. You don't have to keep measuring the values to know what resistors you've got. And then when you get to here, all the components that end in these really big holes, hold off on those. We'll want to wait to do those till later because they need to have a special part put in. So go ahead and do all the ones that don't end in those first. And I'm just going to do resistors to start with. So I can go ahead and do R13. And R7 is next over here. These drawers stick a little bit. Please be gentle with them, because if you dump them all out, everybody's parts are going to go all over the place. And then I'll go do R3. Some of the parts like R3, that value of resistor, the 150 kilo ohm resistor, you need 3 of those. So I've cut them in a lot of cases into 3 so you can grab all 3 at once. And this is R3. R4 is that same value. And also R11. So I'll go ahead and do all three of those at once. Pardon my hand getting in the camera view. That's where I put the drawers. Probably a bad idea. Move those over out of the way. So R4. I'm just putting these in place right now. I'm not going to solder them yet. So R3 and R4. And then R11 is also that same value. So to find R11. R11 is actually on the other circuit board. This one. So I'm going to go ahead and do that. It's there are only three resistors on that circuit board, so I'm going to go ahead and put those on. I'll just set them to the side. And then I've got R1 and R2. Like I said, when they're multiples, I've got them just connected together. So on these that are still on the tape, just pull the tape off the ends. And I go ahead and bend them, put them on. Now the resistors aren't polarized, so it doesn't matter whether you put anything on the top or bottom. A lot of times I will make them so that the colors match if they're the same value, but that's just a visual thing. It doesn't have anything doesn't change anything about the circuit or the functionality of the actual microphone. R2. So then that's all the resistors on this board that I can put in now. Again, I have to wait for R9 and R5, or R8 and R9, these two, because they connect up here to this stuff that I have to wait on. So now what I'm going to do is I'm going to remove the circuit board from the clamp. Now this part, the problem if you keep it in the clamp is that as you turn it over to solder it, all the resistors are going to fall out. So what I do is I set it down on the table. Do it quickly enough they won't fall out. And then you can push it down and then solder them in. Remember, clean your soldering iron every time you go to solder. I'm going to zoom in a bit more so you can see my solders. Go ahead that close, can I? See how close my camera will let me get. That looks pretty good. And then what's nice here is that as I push down just with the iron to solder, holding the components down the way I want them. They do move around a little bit, but it'll work out for you. Process again is iron goes down, make sure it's touching both the lead and the solder pad on the circuit board. Hold it there for a bit to get hot. Touch the solder on, leave the iron on for a bit, take the iron off. It's not getting in the way of the camera. I can't really see the circuit board quite well enough, as good as I would like to solder this. But and I'll just spin it around so I can get to the components I haven't done yet a little bit easier. I get that one. really hard to see some of these from where I am. And then I'll give them a visual inspection. Make sure they all look like they're supposed to. So now we want to cut off our leads. And I think it's really good to cut them off now, not to wait, because they're going to be in your way for other things. So take your cutters, these side cuts. The way to get the right amount of cut is to push it against the lead of the component, let it drop down till it stops, and then cut that there. That gives you the right amount of cut without cutting into the circuit board with a solder. You're not going to cut into the circuit board, but that doesn't cut into the solder then. It just cuts off the lead. Notice I'm holding my finger on it. So it doesn't fling across the room and hit someone. I'm the only one in this room, but I recommend doing it in the lab. So I won't hold this one. Didn't play too far, but do some. Make sure Irish solders are pretty. I see one here that I'm not ecstatic about, so I'm just going to heat it up and let it reflow. It's still not very nice. It's definitely worth spending time getting all the solders to be exactly the way you want them to be, because whether this mic works regularly or not is going to be all about keeping your solders being really good. Any cold solders will show up intermittently. See, so I'm still not happy with that. And part of it's, again, I can't see very well being far away because of the camera view, but it happens. So here I'm using desolderer. This is different than one in the lab, but I can show you the one in the lab. That should just clean that off. And then I can go back in and resolder it. Sometimes, most of the time reheating it works, but sometimes you have to get rid of the old solder. There, I'm happy with that now. I'm happy with all those solders. So that's all the resistors. And the next thing I would do is the next smallest components, which would be the diodes. And sometimes I'll do the diodes and the resistors together because they're very similar size. So we've got D1 and D2, which are both Zener diodes. And remember, the Zener diodes are polarized. So the line, the black line on the component indicates the cathode. So does the line on the schematic symbol that's on the board. So it's going to go in like this to where the black line and that white line line up together. Again, I'm just going to bend it like I did with the resistors just at the end of the body. Put those in. This one goes, faces the other direction. So those are all the diodes on this board. There's some on the other board. I'm not going to show you both boards because putting in components. So now let's go on to the capacitors. I'll go ahead and solder these two. So I'll go ahead, in this case, those diodes both went in pretty tight, so I think I can solder them without them falling out. Yeah, so I can turn this over and they're still staying in place. You do want to make sure that the components are flat against the board. We don't want any air between them and the board. There are occasional times when you would on certain builds if you need like extra heat dissipation, but we don't for any of these here, and it's just going to cause extra noise because we'd have extra bare leads. So again, all of the components should be flat against the board. There we go. And then we'll cut those. Then we can start doing the capacitors. Again, skipping the ones up here that go to these big holes. So C5 and C3. C5 is the first one I see. And C5 and C6 are the same value, so they're together like this. So we'll do both of those. And on the capacitors, when they're on this cardboard, it's a lot of times it's hard to get them off of that. And you're going to need shorter leads anyway, so I would just cut them. Put them in place. There's C5. C6 is over on the other side. One of the things I don't like about these particular circuit boards is that they're one-sided. Double-sided circuit boards are much preferred. And they don't even cost any more now, so I'm not sure why these are single-sided. I'm guessing it's just legacy from the original designs of these microphones from however long ago they were designed. And it's kind of sticking for some reason. So I'm having trouble getting, because I got some solder over onto this hole that shouldn't have been there. Let me clean that off. So if you need to clean some solder off, you can either ask me and I will do it for you, or I will show you how to use the desoldering tool. And if I have time, I will make a video for that so everybody can have a little video to see in case they need to do it. So there's 5 and 6. 3 and 4 are the next two. So 5 and 6 that I just did, those are film capacitors. And then 3 and 4 that I'm getting ready to do look like this. These are multi-layer ceramic capacitors. And we'll have some multi-layer ceramics and some just plain ceramics in this build. The multi-layer ceramics are fairly recent design, fairly new components, and I really like them. Again, I've got some solder off where it shouldn't be. Get rid of that. And then one of my other capacitors fell out. So C6 fell out. So I'm going to put that back in. So don't put too many in before you solder. So here, since these are falling out a little bit, I'll show you a trick. You can certainly put the boards down on the table again, like we did for the resistors, and that works really well for the resistors. Usually for capacitors, because the capacitors are taller, it's kind of hard to do, but it is possible to do. So let me see if I can get the camera angle right for this. I think that's good. So I just angled it a little bit. Hopefully not so much that the capacitors fall out, but enough that I can see the solder points. And one of them just started to fall out. So this one, C5, or C6. C6 is being kind of a pain. So I'll bend its leads just slightly apart from each other. That'll help hold it in place while I solder. The other thing you can do if you're having trouble, solder one lead, check it. If it popped up a little bit, hold the cap with your finger, heat that solder again, push it down, and then take the heat off. And now that's held in place. And then you can do the other solder and it won't fall out. Again, iron goes on, wait, solder goes on, wait, iron off. Always those 3 steps. And we want to make sure we're heating up both the pad on the circuit board and the lead on the component. Those 2 things should be getting hot from the soldering iron, and then they are melting the solder. The soldering iron is not actually melting the solder. You shouldn't be touching the solder to the soldering iron. And the reason for that is then you know that the other 2 pieces of metal are hot enough that you will get a good solder. Okay, let's see what we got left to do. So, got a lot of resistors done, a couple capacitors yet, 16, 17, and 1 and 2. So let's do 16 and 17 first. These are more multi-layer ceramic capacitors. And these all have numbers on them that show you the value. And there's a little cheat sheet in the lab if you want to help look those up, know what the value is. You can also look it up online. There are lots of, if you just search, so these are, those say, I don't think you can see it here. And I can't really read it. I think it's 102. Double check that before I tell you that's what it is. So 15, 16. So you can look these up, the numbers on them, to tell what the value is. And that's what I did when these parts all came in. I also used my special tester to double check that they were what they were supposed to be, because I didn't get all the part values listed on the schematic that I was given. So I was sort of figuring a lot of this out. So there's 16 and 17. Again, notice I'm cutting all the leads as I go. Otherwise it gets really, really messy. I did not get that last one soldered. Another one that I don't like quite so much. So just constantly check all the solders you see and make sure they're good. So now we've got 1 and 2. And that will be all we can do until, all the capacitors and resistors we can do until we get the top parts in. So 1 and 2. These are another of these film capacitors. Again, I'm going to cut them off from the cardboard because it's just a lot easier. Put those in place. Again, flip my board up enough that I can solder. They're a little loose, so I'm going to hold them in place when I do the first solder on each one. And I prefer, when possible, to use the side of the iron. There's a little flat area instead of the very tip. A couple times I was using the tip just to get from the front, so I was trying to keep the iron out of the view of the shot, camera shot. But I do prefer the side. What you want is you want the most surface area from the iron possible, and the side does that better than the tip does. Just transfers heat quicker and better. And that's everything on the top except for the transistors. All the stuff here at the top that we have to wait a little bit on, and this switch in the middle. So let's go ahead and do the transistors on the switch. We'll do the transistors. We'll hold off on the switch. So we're going to do T1 and T2. And in case you're wondering, I've never built this microphone before, so I'm somewhat making it up as I go. But I have built microphones like this, so I know the basic process. Just wiggle that down in. The curve of the outline, the curve of the transistor should match up. And on the schematic, you'll notice the pinouts for these transistors. There are a lot of commonality in transistors on what the pinouts often are, but they're not always all the same. So these are similar to, they have the same pinout as the transistors we used in 112, but not all transistors do. So you always have to check that. So I have 3 leads of the transistors in place. And then cut those leads. And there we have all of our resistors and the majority of our resistors and capacitors for this first section.